Alright, let's talk about this mind-blowing news. China just built a 582-ton magnet for their artificial sun, that's handling plasma temperatures hotter than the core of the actual sun. Wait, what? A magnet that big? And why does this even matter? Let's unpack this, because honestly, this isn't just about magnets, it's about humanity's next potential energy revolution. So first, imagine a machine that can create a magnetic field strong enough to contain something hotter than 100 million degrees Celsius. For context, the sun's core is about 15 million degrees. This thing is 6 times hotter. And the magnet itself? It's 21 meters long. That's longer than a school bus, and it weighs more than a fully loaded Boeing 747. But here's what immediately stands out to me. This isn't just an engineering stunt. This is a statement. China is betting huge on nuclear fusion, and this magnet is their ticket to the next phase of the energy race. Now, why do you need a magnet this massive? Let's get real, fusion is hard. Like, ridiculously hard. You're trying to smash hydrogen atoms together to release energy, right? But to do that, you need plasma, a state of matter so hot it would melt any physical container instantly. So instead, you use magnetic fields to suspend it in midair, basically. The toroidal field magnet is the star here. It's the donut-shaped cage that keeps that plasma stable. But here's the kicker, bigger magnets can create stronger, more stable fields. And that's exactly what China's new design does. It stores 3 times more magnetic energy than previous models. In my opinion, this isn't just incremental progress. This is a leap towards solving the stability problem that's plagued fusion reactors for decades. What's fascinating is how this ties into the bigger picture. China's not just playing around with lab experiments anymore. Their best reactor, the one this magnet is built for, is supposed to move beyond just sustaining plasma and actually generate usable electricity by 2030. Wait, 2030? That's only 6 years away. But here's the thing, even if they hit that target, commercial fusion is still a moonshot. But every time someone cracks a component like this, the moon gets a little closer. And let's be honest, the geopolitical implications are wild. If China cracks fusion first, it's not just about clean energy, it's about dominating the next century's energy market. But hold on. Let's zoom out. Fusion has been 30 years away for 60 years, right? So why is this magnet different? Well, for starters, China's approach to superconducting tech is evolving. Superconductors usually need near absolute zero temps to work, which is a nightmare to maintain. But they're using high-temperature superconductors here, which, ironically, still operate at minus 196 degrees Celsius. It's all relative. This tech drastically cuts energy loss, making the whole system more efficient. And that's a game changer. What many people don't realize is that fusion's biggest hurdle isn't just physics, it's economics. If you spend more energy cooling the magnets than you get from the reactor, you've lost. This design might be the first serious step toward breaking even. Now, here's a thought, why are we even relying on tokamaks like this? They're complex, temperamental, and require these absurd magnets. But the alternative, laser fusion, for example, has its own issues. The truth is, we're in the Wild West phase of fusion tech. Different countries are betting on different horses. The US leans on laser ignition, Europe's all in on ITER, China's doubling down on tokamaks with this monster magnet. And honestly, that diversity is good. Because if one approach fails, another might surge ahead. But let's end on a deeper question, what happens if fusion becomes viable? We're talking about energy so abundant, it could destabilize entire industries. Oil, gas, even traditional renewables might get upended. And there's a moral angle, too. Fusion produces minimal radioactive waste compared to fission, and no carbon emissions. If you take a step back, this magnet isn't just a piece of machinery, it's a prototype for a world where energy scarcity is a problem of the past. So yeah, this story isn't about a magnet. It's about humanity's next giant leap. And whether China's artificial sun will rise first, or if someone else will steal the fire. What do you think? Let me know in the comments.